Hi, my name's Joey. If you're watching this video, then it's likely that either I or a person you know or an algorithm has decided that you might be interested in my project NeuralNextG, which I'm releasing today. It is a machine learning algorithm which I've fed 200,000 Rocket League games into, and with a bit of work, sort of turn this into an analysis tool and a way of analyzing Rocket League games automatically in seconds. The purpose of this video actually isn't to explain in detail how this thing works. I have a blog post which is in the description of this video, which you can read if you're interested in a deep dive, but actually to talk about the web interface and how to use the web interface. But because you might have seen this video elsewhere, I'm going to go for a brief rundown of what this is about and how it works. If you're just interested in how the web interface works, please skip past this point. So yes, because I don't know whether you know anything about Rocket League or machine learning, I'm going to talk about both, and then I'm going to talk about NeuralNextG, and before we take a look at the thing in action. So Rocket League is a game released in 2015. It's really just cars playing football. There's 6 cars, 2 goals, ball. Three cars want the ball to go in one goal. The other 3 cars want the ball to go in the other goal. It is really that simple. The only thing that differs from if you did it in real life is that all of these cars have a rocket attached to the back and can sort of like leap into midair, which would be a lot more difficult in real life with real cars. It is sort of like emergently complex, I think, that even though it's an 8-year-old game, new tactics are being created and it always feels fresh, even at the level that I'm playing it on, but also at the pro level, there's new ways of scoring, and it really feels a lot more like a sport than just sort of your standard video game. It has a massive player base of millions and a thriving esports scene, sort of professional leagues and stuff like this. It's really just the best game, I'm afraid to say, at least in my opinion. Okay, so what is machine learning? Machine learning, you may have heard of. Artificial intelligence, you're more likely to have heard of. These terms are sort of interchangeable, so it brings up ideas of robots or automated systems, stuff like this, which are intelligent. They're essentially just algorithms, which are computer programs, which learn to get better when you give them more data. That's what machine learning is. Over the past 10 years, because there's been much cheaper computation due to Moore's law and data capability and much more data due to Web 2.0, so people posting pictures and stuff online, lots more sort of user created content on Facebook, Flickr, whatever, anything you can post stuff on. That data sets can be created from that data and then fed into machine learning algorithms running on more powerful computers and create these machine learning algorithms. And this is essentially something that's only been possible over the past 10 years at scale, essentially. And all of these, not all of these, but a subset of machine learning that is, as far as I'm aware, I believe sort of the most popular is supervised learning and the most successful, where you give a computer a task and the example of the task done successfully and it learns to do the task. So the canonical example is, say you want a computer to be able to tell the difference between a picture of a cat and a picture of a dog. What you would do is, instead of creating sort of a classical computer program which takes an input and does sort of has instructions of what it should do to this input and produce an output, so check whether the picture has a leash in it, or check whether the picture is playing with a piece of string, which is sort of a way that you could try and train try and create a computer program which could determine between a cat and dog. You instead just give a algorithm 10,000 pictures of cats and 10,000 pictures of dogs, and then you say, learn to discriminate between, this is a picture of a cat, this is a picture of a dog. And that has, over the past 10 years, worked so much better than the typical sense for a lot of cases. And this is essentially what I've done with NeuralNextG. Because essentially what I'm trying to do with NeuralNextG is take every single moment of a Rocket League game and predict who's going to score next. So that's where the name comes from. The neural network, which is a machine learning algorithm, predicts the next goal. I chose this name because it sort of reminds you, if you follow football, of XG, which is expected goals. So they take shots in football games, football matches, and they see who they try and put a probability on what whether the person who was going to take the shot was going to score, because you look at sort of just like all shots and you say, and some of them are good, some of them are bad, based on how close they are to the goal, where people are, etc. But it's actually quite a simplistic model, because in football you don't actually have much data. The real cool, exciting part about working with Rocket League data for me is that we don't need to wait for just shots. We can take every single moment of a Rocket League game and get a good prediction of who's going to score next. And that means that you can look at a lot of stuff like a pass, and you can see how important a pass was, or you can see whether there was a mistake with the positioning of players, etc. And this is how I've applied machine learning to Rocket League. And really well, not all I've done, but to create this data set, I've taken every single frame of these 200,000 games and taken the position, velocity, boost of the players in the ball, and given it a label of, oh, blue scores next, orange scores next, etc. And it has learned to make really good inferences on each situation and who is likely to score next. It's the games themselves I've trained it on are between champion and supersonic legend rank. I've added stuff into the model so it can actually take into account what rank a game is when it predicts who's going to score next, which is very important, because a situation at champion level will be much different to one at supersonic legend level. For somebody who hasn't played Rocket League before, these are champion to supersonic legend are sort of like the top ranks, and this is where the games come from. And because it's a computer program, the actual analysis of these games can happen in a single game, can be analyzed in a few seconds, really. So this is stuff that can automatically happen. That is NeuralNextG, and this is a picture of the web interface that we're going to go over in just a minute. I just want to quickly talk about why I've done NeuralNextG, or like what we can use it for, and what the possible next steps are. So at the moment, you can log on. Well, not log on. You can literally just click on scrumps.dev, click on any game you're interested in, and sort of start looking at what NeuralNextG is predicting and who's the next goal. And that is free. There's no ads, no cookies. Next steps here are, firstly, is we can look and find Smurfs or bots automatically by just looking at games that have been submitted. We can automate highlight reel or coaching tape compilation for players of the game. So with no human intervention, we can create a data product for these players, basically by just taking all their games and taking, these are the parts where you played as if you were a professional, and put all those into a nice highlight reel, and then create another highlight reel which is like, oh, these are the plays where you could have done a bit better, and that could be of interest to users. And then another point is automatically scouting pro players. At the moment, there's a massive pro scene, but you could have a bunch of players who are currently obscure and nobody knows about them playing, who are able to play at a really high level and play like professionals, but they haven't actually been signed yet. And you can use data mining combined with NeuralNextG to find these players. And I'm really excited to collaborate with anyone who's interested. So really, my email is in the description. Send me an email. I would be really excited to hear from you. Anyway, let's go and talk about the web interface. So now what we're going to do is we're going to look at how to actually use the web interface. So this is the NeuralNextG interface. So you can see that this is scrumps.dev, which is my website, /games/NID, and this is the ID of the game. You can see already in the top bar that this is Solary versus Tundra Esports, and this is game 1. Yeah. Other things we have here, we have matches. So this is going back to this sort of menu where we can look at all the different games that I've put up. There's roughly 300 of them. They are from recent European. So it was last weekend's. It's the 18th of February. So it's last weekend's, the 11th of February's esports tournament, the European one. And I just downloaded all of them and have passed every single one of the games that have been played where the replay file was available. It's like I can do it for more recent ones. I haven't set up that to do it automatically yet, but yeah, that's in the pipeline. But for now, there are these 300 games which you can have a look at. So what we can do is I'll go back and load this game. So just refresh it. You start out at this page. And what I'm going to do to start with is to tell you how to use this page, basically. So yeah, that was back to matches. We have this little help thing here. So this is basically in text trying to describe what I'm trying to describe to you now. I'll also probably put a link to this YouTube video at the bottom, so that's very meta. But yeah, that's so you can come back to this if you need a reference. Then we have the play button or pause button, so this is to determine whether this thing starts or stops. We can do the same thing using the spacebar, so I've just placed the spacebar there, and then press the spacebar again to stop it, so you can see that the game continues. And then this is the speed. You can speed up the game, so it plays it 3 times like this if you really want to just scan through and see what happens, or you can go really slow, like 0.1 times, where it gets a bit framey, but you can sort of see exactly frame by frame how everything develops. So this is the top bar. There's all the buttons at the top bar. This clear loop I'll explain a bit later, but it's not currently relevant. This thing right here, this is the XG, the NeuralNextG bar. So this essentially is a number from 0 to 1. At 0.5, it's saying, and what 1 means is that it thinks there's a 100% chance of blue scoring next. 0 means that there's a 0% chance of blue scoring next. So whenever the line is below here, then orange is in the advantageous position. So Solary is in the advantageous position. Whenever it's above the line, blue, in this case Tundra Esports, is in the advantageous situation. So that's kind of the cool thing to start with this, is that we can open up a game like this and we can see exactly, not exactly, but we can get a rough idea of what happened in the game. In this game, it was quite, so I've looked at quite a lot of these. I originally created this tool to debug the neural network, but it turned into sort of like the actual product itself. But this is essentially, you can look at, if you look at all the games, they come in different flavors, and this one is kind of a straightforward one. I'd call this a straightforward game, because there's not really that many chances. There's this one here that didn't turn into a goal, but all of the other really good chances here turned into a goal. So it's a really straightforward game. If we compare that to something like this one, this is a game where, sorry, I didn't explain. These vertical lines here, this vertical orange line means a goal for orange. This vertical line is a goal for orange, goal for blue, etc. So you can see at the end it's 1, 2 for orange, and then 1, 2, 3 for blue. And then this axis is time. So as we play the game, we just go through, this red line, which is where we are in the game, moves forward across it. So yeah, you can see this is kind of like a back and forth game, no real big chances that don't end in goals, almost like a defensive stand, you can kind of see here. Then if you look at this game, it seems like the action never really ends. It takes a decent amount of a chance, I've found, with NeuralNextG to move it from 0.5, because it's quite conservative in a situation like if we go back to something like this. Even though we have orange here, I will explain how this 3D model works in a bit detail a bit later, but you can see that there's these 3 orange cars. They're in a relatively good attacking position, but even still, NeuralNextG is only giving it 45%, and that's because it had so few chances typically end in a goal that it has to be conservative to well, this is the actual percentage chance it believes that orange is next to score. Yeah, so this is the point, is that like once we get to sort of like even 60% or like 0.6 here or 0.4 here, stuff like that, these are sort of like significant chances essentially. So you can see here where it seems like every other second there's a chance. This is a very high sort of attacking, very dicey game, which is exciting. So this is an exciting game. So you can already get sort of a sense of this is how you can load this thing up and in a second have an idea of this is what this game looks like. So I've got this other third cherry-picked example here. And so like, what would you say, like looking at this here, I'll give you a second to think about it, but like, what would you give as the story of this game? We have a goal by blue at the start, then a goal by orange, and then a goal by orange at the end. Because for me, instantly looking at this, I see, so yeah, it started off 1-1, and then a lot of the game was 1-1. what happened in that period. You can instantly see there were 4 amazing chances for blue when it was 1-1, and then in overtime, because these are sort of like in milliseconds, so this would be in about 10 minutes, orange scored at the last minute. So this is a heartbreaking defeat for blue here, because blue had all of these different chances. So this chance, so like 80%, again, sort of like, yeah, like 70% there, etc. So it and then even more, so this 80 and 70 again. So just by reading this sort of XG plot, we can get a sense of what happens in the game without having to go into the middle detail of it, or even watch the whole thing, which is exciting. And obviously you could also do this with the statistics in game of like where the shots happened, etc. But anyone who watches Rocket League or plays it will know that not all shots are made equal. So maybe a shot like this was sort of a chance happening here. This could have even been a shot with the shots on goal. But yeah, if we see here, we go back and then we play this. So this is a shot here, and this would be registered as a shot in the Rocket League sort of game. The game will be like, oh, here's 10 points because you just did a shot. But you can see from the ball's perspective, there's somebody coming to block it, and this person is going to block it, essentially. And so the model says, okay, there's a chance it'll go in, this is 60%, but like realistically speaking, it's not an amazing chance. So yeah, you can sort of really see these heartbreaking moments in NeuralNextG, which is really exciting. Yes, so that's why the bar is really useful, and as I've sort of shown you, but to be explicit, you can click anywhere on the game on the sort of bar here to move to that point in time. Again, these are in milliseconds, so if I wanted to go to the time axis, I will definitely fix at some point, but you can go to any point and click on it, and you end up at that point, and then you press spacebar to keep playing, and then you can go backwards and forwards from any point, but this is the way you sort of navigate around it. Yeah, and then this is an added feature I've put in here. If you wanted to look at a specific thing, a specific time period, what you do is you click, so I've clicked now, drag across, and it will zoom in to the area I've just dragged it on. And then if I play it from here, it will so I'll speed this up. It'll go through and play this time period that I've been interested in, and then once it reaches the end of the loop, it'll start at the beginning again. So you see this a lot, for example, in NFL tape review, that you want to look at a thing over and over again, and so you can say, oh, look at how this orange player was moving, now look how this blue player was moving, etc. Yeah, that's just a little feature, and this is what the clear loop button is for. When you want to get rid of that, you can clear loop, and then you're back where you were before. I'm not sure if many people find that useful, but yes. Okay, cool. So now let's go and look at actually this 3D representation. So I've been using it and maybe get a rough idea of how it works, but it's a bit more complicated than it seems. So firstly, when I was using user testing, I realized that people didn't realize you can click and drag it to rotate the pitch. So this is something that you'll want to do, because this angle that it starts at is fine, but you don't get to sort of like dig into the game or to the details of where people are. One thing, you can scroll to zoom in and zoom out. You can also right click and move to pan it, but yeah, sometimes that ends up making it a little bit sticky. If it does, then refresh the page. And then the actual visualization, these cubes, not cubes, I would guess they are cuboids, are the cars. I haven't turned them into real cars yet, but actually I've made it so these cubes are kind of illustrative of different pieces of what's the word? Illustrative of different properties of the cars. So you can see that like the sides here are orange, and they're all the same orange. You then have this top part, and for the other team, they're obviously blue. Then for the top part of this of the cars, they are a darker orange. The reason for that is that this is the representation of their boost. So when this is a darker red, they have more boost. When this is the same orange as this, they have 0 boost. This is so when we pause in time, we can look at how much boost a player has without having to represent it in text. So yeah, so this is the start off, the kickoff thing, which we're all used to. I've also shown here at the bottom of each of the to show the top and the bottom of the car. I've made the bottom of the car a darker orange and a darker blue, so you always know which way the wheels are. But I haven't actually put the wheels in. Okay, so yeah, we can sort of see how the boost thing works. This car has gone directly to the ball, and in Rocket League you use all of your boost to get to the ball. So therefore its boost top part of the cuboid has turned completely pale orange, so it has no boost left. This car hasn't used its boost at all, so it's still at the 20 boost that you start off with. But then this car over here is just about to reach the boost pad, which is in this corner. So when they get to that, they will get 100 boost, and then they get a red top. So this means that they have 100 boost. And then this gives you sort of like a snapshot of which cars have boost, how well are they doing, etc. Another thing I forgot to add is actually at the back of the cars. So here, I've had it so when they are boosting, this is in red. So so we can see that this car, if we go slowly, as it drives over the boost pad, the boost is off, and then they turn it on, essentially. So we can then see when people are using boost, etc., and that could be useful for analysis or something. I just put this in because the model also uses this, right? The model knows how much boost the player has and whether they're using boost, etc. So yeah, I thought it'd be interesting also for you to see. Okay. So what next? So in this game, I thought there was a sequence that, let me just think, is there anything else that I want to talk about? Right, no. This bar is also extremely important. So let's go to here. This bar will tell you at any point in time, at any frame, the frame you're at right now, exactly what the value of NeuralNextG is. So 28% means that blue the model thinks that blue is going to score next. There's only a 28% chance of blue scoring next, so therefore there's a 72% chance of orange scoring next. And you can see that frame by frame, I'm moving frame by frame forward here, it will track the movement of all of the different cars in the game, their boost, everything about them, and then the movement of the ball to see what the percentage chance is of orange scoring. So as the ball heads towards the wall, and orange has a chance to hit this here, so a relatively decent chance. The actual shot itself comes off really well and heads down towards the goal, and just misses, essentially. So you can see that it's sort of come off the top, the crossbar there. So then it goes down, and then once blue gets to it, and the model is understanding that the blue, what happens here? Yeah, so blue does a quick aerial and kicks it out. You can see also, here is a good illustration, I moved back a bit there, that the ball's color is the color of the player who touched it last. The reason why, or color of the team that touched it last. The reason why I did that is because now we can see in this frame, the ball goes immediately from orange to blue. So this is moving forward, and the model really likes the touch that this blue keeper did here. So the chances of orange scoring goes from 37% to when blue hits this off the corner of their car and clears it out to 47%, which is a much safer place for blue to be in. So the model really likes that, and you can see, you can go into the specific hits and see how did the probability change, which is really cool. But there's a sequence of play which I really liked in this game, which I thought illustrated the power of this model, essentially. So this game is Sonics versus Much Delight. Let me try and find where it is. Here it is. So you start off here with, right, so blue has a pretty uninteresting shot here, essentially. So the ball sort of dribbles towards the goal, and I don't know. It's not too bad, but we have an orange player here with full boost, an orange player here with full boost, and the model thinks that despite the ball sort of trickling towards the goal, that one of these two is going to get it. So 52%, not, it's okay. It's sort of like interesting for blue, but not amazing. But the thing that's interesting here is that both of these two orange players are going to go for this ball. So you can see in slow motion, and for anyone who doesn't watch Rocket League, like a double commit is typically a bad idea because you have two players who are both going for the same ball on the same team, both wasting their boost and have the possibility of interfering with one another. So it normally points to sort of a breakdown of communication, as far as I understand. So at this point, both orange players are about to touch the ball. Neither has. The first touch by this orange player isn't great. But even worse than that is that the second orange player comes in and bashes this orange the first orange player. So now what you have is the ball is sort of like trickling sort of this way to this direction. You can see there is no one between the ball and orange's goal, and you have two blue players traveling towards the ball with full boost. So already, because of this action, essentially this off-ball action by these two orange players, and the fact that there's no one here for them, the model is already giving sort of like a high percentage chance that blue is going to score. So let's see it happen. So then we have one of the blue players come in and do an aerial. Again, we have no one in goal. We have this blue player coming up to try and shoot. They hit it against the backboard, which in this sort of level of play is like a very common way of getting the ball in to score, essentially, because you can control it against the backboard. And as it sort of dribbles down, we have a blue player here with completely full boost, the ball coming downwards, and the model is saying, okay, this looks really good for blue. But you might be wondering, well, okay, so this blue player has a really good shot on goal. This is a sort of RLCS match. These are professional players. Why isn't it giving more than 65%? It's because we still have an orange player here who has essentially full boost, and the model thinks that there's a chance that if this player doesn't strike the ball right and the orange player doesn't get back, that it will result in a save. It could easily be a save. So it's only giving a 65% chance. So at the point at which the blue strikes the ball, it goes up to 82% because they strike it true. And now it's sort of like a race between orange and the ball to get to the goal, and the model doesn't really believe that orange can get there. And then as it becomes so it's still pretty close, but as it becomes clear that it's completely past them and that it looks like blue is about to hit orange, it like the model is like, okay, well, this is a goal for blue, which it is. And I think that's kind of like an exciting part about NeuralNextG is we can go frame by frame, look at the decisions made by the players and see how did these affect the outcome of this sequence of play. Yeah, so that is one example of how you can look at these games using NeuralNextG. But I think one thing I'm excited for is that people can look themselves and they can see, oh, I looked in this match and saw XYZ, etc. And finally, thank you so much for taking the time to watch this video. It's been a really fun project for me, and I am excited to see what happens next. Yeah, so take a look at the actual site itself at scrumps.dev. My email for this project is neuralnextg@joey.computer. Send me an email really about anything, whether it's a comment or collaboration or anything. Let me know. On Twitch, I'm joey.computer, and I think I will be doing some RLCS analysis when I get the time and when the time zone fits me. And then for more sort of like, if you're coming from the data science side, please follow my Substack, because I'll talk about new releases of NeuralNextG and maybe other projects that I'm working on. And yeah, and again, thank you so much for taking the time to watch.